Right, so now we need to look at parametric equations for a circle. So, a circle goes round and round and round, and we have to track those points in time. So if we've got a circle going round and round and round, then our circle, wherever it may be, could have a radius of r, and we'll be looking at the x point. So this is our x distance, and this is our y distance here. All right, so that point there, xy, can be found as it goes round and round and round using trigonometry. So we're using sine and cosine. So the x distance is actually x equals cosine theta, cosine theta, and y equals r sine theta, because it's the opposite and x is the adjacent. So we've got these equations here that are actually going to go round and round and round. If we square these, we would get, so these are our parametric equations, all right? They can be mapped up with this diagram by using x squared plus y squared equals 1. So we can actually use Pythagoras to prove that these are actually what we have. So if we've got x squared plus y squared equals r squared, right? Good old Pythagoras. If we now rewrite this as x squared over r squared plus y squared over r squared equals r squared over r squared, which is 1, then we get this. But we also know that x over r squared is the same as cosine squared of theta. And y over r squared is the same as sine squared of theta. And one of our trigonometric identities tells us that sine squared theta plus cosine squared theta equals 1. So we can map all of that together to end up finding out that these are the correct parametric equations. So what we have here is everything being measured in terms of theta or t. Sometimes these are written as t, so it could be cosine t and sine t. That's okay too. But that's it. They're actually given to you as such for you to be able to use on a formula sheet. So, what sort of question could we get? Quite often in this paper you're expected to be able to write it as a parametric equation and also in the Cartesian way. So x's and y's being Cartesian, in terms of t as being parametric. So let's have a look. Find the circle. Defined by x equals 2 cos theta minus 1 and y equals 2 sine theta plus 2. All right, so I've added these other bits on, got these bits here, because they're the movement. This is the x movement, this is the y movement as far as the circle is concerned. We want to find the circle as a Cartesian, x and y only. So we need to rewrite this. We're going to rewrite each equation. So x plus 1 equals 2 cosine theta. These numbers always will be the same because it's the radius and a circle can't change its radius halfway through. So it will always have 2 sine theta. So now we've got our x plus 1 and our y minus 1. It's starting to tell a story. What we have to do next is square both sides. So we've got x plus 1 squared equals 4 cosine squared theta, and y minus 2 squared equals 4 sine squared theta. All right? By doing that, we're now starting to get to the point where we can eliminate sine and cosine. So cosine squared theta is now going to equal that thing, x plus 1 squared divided by 4, and sine squared theta is going to equal y minus 2 squared divided by 4. As we said over here, they equal 1 when they're added together. So we're going to get x plus 1 squared over 4 is equal to plus y minus 2 squared over 4 equals 1. All right, now we're going to get rid of those 4, multiply them on the other side. X plus 1 squared plus y minus 2 squared equals 4. We've now got our Cartesian equation. We can tell that the centre is at -1 at 2, and the radius is 2, square root of 4. So we can manipulate that to get between the two formulas.